Good morning, my superhumans. I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. I just noticed that my video is jumping around like crazy. I don't know what that is. Maybe it's just things getting caught up because OBS has just started broadcasting. So I'm sitting here with a Sunday morning drink, nice glass of dihydrogen monoxide. Vintage is Melbourne tap water, which is pretty good vintage. So I hope you're all doing really well on this Sunday morning. So here in Melbourne, we have just gone back into stage 3 lockdowns, which means you're not meant to leave the house for anything except essential trips, like seeking medical attention or buying food, or if you're working and your work requires you to be away from home, or I don't know, there are a couple of exemptions like that. But basically, we're all meant to be staying home for the next 6 weeks. And when I started doing these regular weekly live streams, that was when the last period of lockdown happened. And a large part of the reason for it was wanting to have some way of being able to connect with people and not feel so isolated. And being able to talk to all of you every week is a really big deal in terms of my own mental outlook and having something to look forward to and being positive. I've just seen a couple of people say hello. So we've got Ecognito3, Frank is here, Unexpected Maker, so Sion, Cable Tie is here, Pancake Legend, hey Mike, good morning on IoT Hoff is in Adelaide. Sion says it's my fault we're in lockdown. Alright, so got to give up live streaming and then the lockdown will be released. Ragnare, 3 AM at Estonia. Oh, that's rough. Are you up very early or very late? Estonia is amazing. I've mentioned this before, but I went there a couple of years. When was it? It must have been about a year and a half ago. I went there because I was on a work trip with MariaDB. When I was working with MariaDB Foundation, I went to Finland, and then from Finland went for a trip over on the ferry to Estonia, and it was fantastic. I loved it. Just before Christmas, the Christmas markets were there, and we got to stand in the snow and drink hot mulled wine. It was very, very nice. Yeah, so I got to hang out in Tallinn for a day, and it was dark and snowy and medieval and awesome, and I loved it. It was one of my favorite parts of that whole trip. So, Ragnar, thank you for watching from 3 AM in Estonia. Okay, now I have a couple of questions that have been posed by patrons and GitHub sponsors, and I'm going to just cover them very briefly now because they're kind of general questions and they're the sort of thing that would be interesting to get feedback from other people as well. So let's have a look. James O asked the question, what are the most and least reliable parts of my system, and or your system, or any home automation system? He goes on to say, it could be anything, programs, hardware, etc. Perhaps something like a piece that worked for a while and kept failing and was replaced, versus something that was turned on 5 years ago and hasn't turned off or failed since. Alright, I can give you an answer for the most reliable part of the system. And for me, the most reliable part is MQTT and the Mosquito broker. Now, of all of the things that could go wrong on the system, the message broker is probably one of the most critical because everything relies on it. It's the backbone that links everything together. My video is still jumping around all over the place. Am I coming through okay? I hope I am. Um, so, um, the message broker is the thing that everything needs to tie into in order to pass messages. So messages from sensors and messages going out to actuators. If the message broker is not working, nothing is working. So it's really critical that it is reliable. And my introduction to MQTT came through my friend Andy, who is here in the chat somewhere. And I think it must be something like 10 years ago. I was thinking back to how long this was. It was not long after one of our first mini-confs, I think, so it must be maybe 11 years ago. Andy and I sat with a laptop on my back veranda with our feet on the steps and installed Mosquito on a computer that was running in a cupboard. And the computer was, what was it? It was a little, I think it was like a ASUS triple E PC. You know, one of those little compact Linux-based machines. That's what I was using to run my home automation system. And at the time, pretty much my whole house ran on a PHP script. And so Andy was showing me how MQTT works and explaining the basics of messaging to me. And we installed Mosquito. I can't remember if it was packaged at the time. We may have even had to compile Mosquito from source and set it up on Linux. And then since then, obviously Mosquito has been updated. I'm now running it out of packages, so it gets regular updates and all of that sort of thing. But in all of the years since, so around 11-ish years that I've been running Mosquito as the basis of my home automation system and MQTT, it has never failed, not one single time. Excuse me. The Mosquito server or broker has never crashed. Like, it's never just bombed out or had a fault like that. To the best of my knowledge, it's never failed to pass a message on. And that is actually quite amazing. It's one of those things where you install the software and it's absolutely rock solid and never fails. So my confidence level in MQTT is really high. I know a lot of people, when they start setting up automation systems, whether it's something like home automation or industrial automation or whatever, they'll look at the messaging layer and think, oh, that's dangerous. That's a single point of failure. It's something we really have to be careful about. And in the early days, I had a little bit of paranoia about it as well. So I used to think about things like, can we set up multiple brokers, like a failover pair of brokers? And this sort of topic comes up from time to time on the Mosquito developers mailing list and in other places. But the reality is that I've been running a single broker as the core of my system for a decade plus, and it's never failed. Now, that's not necessarily... no, I'm giving you anecdotal evidence here, but this is my experience. I can't say that this is going to be the same for everybody. Your mileage and so on may vary. Now, I saw a couple of people here say that the least reliable part of the system is the humans. Yes, human error. Everyone can stuff up configurations, everyone can make mistakes when they're using things, so yes, Eon said, I'm the least robust part of my system. Yeah. Oh, and Matt Richards made the interesting comment. For me, RabbitMQ going slow over time. I moved to MQTT and problems went away. That is really interesting. So I talk about MQTT fairly frequently. I'm just going to switch something in the background here. Okay, cool. So I go on about MQTT quite a lot, and I never mention other message brokers or other messaging systems. Just popping out chat here so that I can have a better idea of what's going on. And if you listen to me, you might think that MQTT is the only messaging system, but it's not. There are many other message bus type systems, and there are also different brokers. So you can run MQTT as the protocol. Mosquito, excuse me. Mosquito is just one possible broker that is compatible with the MQTT protocol, and it's kind of the official reference implementation, but there are other brokers as well, and there are other messaging systems. So there are things like RabbitMQ and a whole lot of others. And yeah, I don't have experience with them. The thing is that I installed MQTT with Andy's guidance all those years ago, and I'm still just using it, and I haven't really looked into others. Alright, so that is my answer for most reliable part of my system. Pretty much everything else has failed at least once. In fact, I had a failure last weekend, which was totally unexpected, and I haven't pulled it apart yet to see what's going on. And it is what you would consider probably the simplest part of my entire system, and that is with a passive PoE injector. I've got I've got two small racks that are used for the automation gear. I've got one at the west end of the house, one at the east end of the house. Both racks have a small rack mount PoE injector in them. Now this injector is, how to describe it? It's basically pairs of RJ45 sockets. The RJ45 sockets are wired through, except for the pairs that need power, and they have power going to them. So there is a power input coming from a plug pack power supply. That power is injected on spare pairs. And so all it really is a power splitter. You could think of it that way. There isn't even any active electronics in it. It is literally like a 2.1 mil socket with connections through a PCB to some RJ45 sockets. And last weekend, the whole west end of my house stopped working. That's because my house is split into two zones. I've got all the automation for one half of the house coming from one switchboard, the other half comes from the other switchboard. And what happened was all of the light switches stopped working, all of the outputs stopped working. Now, Node Red and everything was still running because the Raspberry Pi was running everything. But the thing is that I use power over Ethernet to power the light switch controller and the controller that goes in the switchboard that drives all the relays. Most things are powered by PoE. And I thought that I was not going to have a problem with that because it is just power spliced into wires. And I actually thought that the power supply had failed. So when it died, there was no power shown on the injector. I thought, power supply has died. So I pulled out the plug pack, grabbed another one, plugged it in, shoved it in. Nothing. What the hell's going on with this? So I got a multimeter. There was voltage on the plug pack, but for some reason the injector is not passing any power through. So I just unplugged the cables from that injector, plugged into another spare injector that I had sitting on a shelf within a meter's reach, and got everything back up and running again. What I still need to do though is pull the original injector out of the rack because it's bolted into the rack and have a look, see what's going on. I don't know, but that was a bit of an unexpected failure. Normally failures happen in the complex parts of the system, not the thing that's just essentially a bit of wire. Alright, so I'm interested to hear from other people as well. But what's particularly interesting are the things that fail. And because those are areas where there is an opportunity for improvement. Hey, Peter! Thank you for the donation, the support. Station 240 said, normally failures happen at Sion's place. Oh, very sadly, that is true if it's related to pick and place. Let's leave Sion alone about that one. He's frustrated enough without us bringing it up more. So areas where there are failures are opportunities to fix the system. It's a little bit like optimizing a system or optimizing code. If you run a program and you profile it, so you see where most of the execution time or the CPU cycles or the memory or whatever your metric is that you're trying to optimize is being used, then you focus on those areas and make them better. That's where you get the biggest wins. So being aware of areas that are failing is important. Now, in classic chasing squirrels fashion, this is sending me off down a track that I could follow for a while. I had some things to show you, but I will chase this squirrel just for a little bit. Now, one thing that I came across many years ago, which I found was really interesting, and I want to cover this in a bit of a more structured way in the future, is the problem of perception of unreliability. Now, I came across this concept quite a few years ago, and I can't remember where I found it. I'm going to have to look it up again. But it was a study in relation to the psychology of how people react to unreliable systems and their perception of how unreliable it is. And there is a trade-off. So, all right, two scenarios. And I think this, as I said, was many years ago, so my memory is hazy. I think this was based on an actual study. Someone set up a test environment and then and then used test subjects to expose them to these different environments and then checked on their reactions to them. So there may be actual proper academic basis to this, but and these numbers may not be correct. I'm just making this up to illustrate. So the general concept goes, if you have a system, okay, so you have two systems. One of those systems goes down or has some fault that that takes 1 hour to recover, and it fails once a month. Okay, so per year you've got 12 hours of downtime for that system. And then you've got another system that fails once a year, and when it fails it goes down for 12 hours, and then it's fixed, so then it goes for another year, and then it's down for 12 hours. The way people perceive the reliability of those two systems is totally different. Even though the total availability or uptime or downtime, however you want to measure it, is the same. People who are subjected to a system that goes down for 1 hour once a month will perceive it as being terribly unreliable. They can't trust it. It breaks all the time. They never know if it's going to be working or not. Compared to people who have a system that goes down for 12 hours once a year, it won't even cross their minds that there's any problem with it. They'll think, yeah, that's reliable. Like, it might have a problem occasionally, but I can't remember the last time it had a problem. And it's partly related to recency of exposure to the failure. Even though the experience of the failure is the same total duration. Anyway, you get the idea. It's a really interesting area, and it's something that in home automation is a really, really critical factor. Like, if you have a system that has small glitches constantly, it's going to drive people crazy, and they are not going to have faith in the system. But if your system dies totally, say once a year, and you have to get someone out to fix it, that is far more acceptable from a psychological point of view, and people will see the system as being relatively reliable. I think it's a bit of a case of it's a couple of factors. I mean, I don't remember the results of the study, but I think part of it is the recency. So how long is it since you last experienced a problem with the system? And part of it is the unpredictability, that feeling that you never know if when you press that button it's going to work or not, because you have this, niggling feeling in the back of your head. So, oh yeah, Peter said humans suck at perceiving time. Yes, absolutely. So I've hang on, I've just got to bring my back channel back up again, because Andy is very kindly watching the chat and trying to prevent me from missing things, because I spend so long off chasing rabbits that I miss most of what people say. Okay, so yeah, Rule 18 made the very good point that my concern about MQTT isn't the MQTT, but the network it sits on. Still, this gives me lots of confidence about using MQTT. Yeah. Yes. So the thing is that when I say MQTT has never failed on me, I mean that the failure has never been caused by MQTT, but I have had times where the network has failed, like an Ethernet switch has died. I've had multiple Ethernet switches fail, and I've had that PoE injector fail. I've had Ethernet cables fail, like just patch cables stop working. So there are many causes of error, and if you lose your networking, then other services that sit on top of it, like MQTT, aren't relevant. And James O'Gorman points out that reliability and how your system is built to fail. So being able to fail gracefully is really important. There's been a lot of interesting discussion about this on Discord in relation to light switches, and setting up light switches in a way that you have automation, but if the automation system fails, you still have manual control over it. And there's a sticky forum thread. Is it sticky? No, I don't think it is. It should be. There is a forum thread at the moment. Maybe I will even put this in. Let me grab this URL and I will stick this in the chat. So this is the light switch thread on the forum. And part of the discussion of light switches is this whole question of, okay, so your little Raspberry Pi dies and now you can't control your lights. What do you do? Yeah. And yeah, oh, Mike O'Connor made a really interesting observation. So on previous live streams, I've mentioned Mike's work. So Mike does industrial robotics sort of stuff where he builds these amazing systems that are used in wool sheds for handling bales of wool, after it's been removed from a sheep. And he made the comment that the wool sampling lines I help build have this issue. If they have too many problems early on, the operators seem to think they are unreliable forever. Yeah, that's right. Once that perception has been set, it's very, very hard to break that. You can have a system with a few teething problems early on, and then the operators will start to think, oh, this is unreliable, I can't trust it. Once you get them sorted out, it might be perfectly reliable after that. But in their heads, that doubt is still there. So you really have to overcome that. Yeah, oh, and David Cole just said, I think that's why Z-Wave or Z-Wave, depending on what continent you're on, and Shelley's, etc. are so good. As long as the individual components still work, even without automation, the switch is still just a manual switch. Yeah, yeah. So there are some really interesting design considerations here that you really need to think about when you're setting up an automation system. Okay, now I'm Oh, yeah. Oh, and Andrew just pointed out, Andrew Gordon said, I think most or all of my Ethernet switch failures have been their power supplies. I've had a dozen little D-Link, I think they were gigabit switches, power supplies on every single one has failed. Yeah, replaced the supplies with ones from JCar and they've worked ever since. Yeah, and there's another classic failure that happens. I wonder if I've got one here, because I... No, I don't. I think it must be... I had a little D-Link Ethernet switch. Hang on, I'm sure I've got one fairly close. In here somewhere. No, maybe I don't. I know I do out in the garage, but I won't make you wait while I go and get that. There is a classic failure with the little blue Netgear gigabit Ethernet switches. Yes, they're really common, and they're the unmanaged Ethernet switches that are typically desk mounted, and you can get them in like 8-port and 16-port skinny things about this sort of dimension in metal cases, and they're generally very, very good quality, but there is one specific way that they fail. It's the classic thing, because they don't have fans in them, they're designed to be passively cooled. They run warm. I won't say hot because they don't really get hot, but they're definitely warm. Like you touch them and they feel quite warm while they're running. And what happens over time is the electrolytic capacitors in the power supply inside the switch dry out, and then when the capacitors fail, the Ethernet switch can fail either totally, or it can fail in a really strange way, which is that I don't know why this happens, but basically it starts dropping frames. And I think it's because the power supply in the Ethernet switch just becomes a bit too marginal, and when the Ethernet, when the main processor in the Ethernet switch is trying to do its packet switching and all of the stuff that it does at the low level to route data around between the ports, it runs out of power, maybe it browns out or something, and you start getting network errors running through the Ethernet switch. And it's because the capacitors are drying out in the power supply. So I've actually got a number of Netgear little gigabit Ethernet switches that people have had and they failed. And I've said, hey, give it to me, I'll take it. And then you open it up, you replace the electrolytic capacitors on the PCB, close it up, and it all works fine again. So, yeah, power supplies. Power supplies are... Why does everything come down to power supplies? They suck. That is very painful. Okay, now I'll try to catch up on a couple of these comments. All right, so some of these comments are from a little while ago, but I'll try to catch up quickly. MD80 Gaming asked what I think of Loxon. I've never known whether it's pronounced as Loxon or Lox1 or LOX1, I don't know, which are home automation systems and devices. I don't have any experience with them. The thing is that I'm kind of just making this up as I go along. I'm not a home automation expert. So you can all leave the live stream now. See, it's been nice. I'm just trying to figure this out as I go. So I don't really have exposure to a whole lot of commercial gear in particular. One of the reasons that I started doing this, partly because I wanted to understand it, partly because I wanted control and the flexibility of building things myself, also partly because I couldn't afford it. If I had had money back when I was getting started with home automation, and I could have just gone to a C-bus integrator and said, here's $100,000, automate my house, I probably would have done it, and I wouldn't have gone down this track of figuring all of this stuff out myself. But most of what I've been doing is trying to cobble together things with little bits and pieces and design things to solve my own problems without going out and buying commercial stuff. So I don't actually have very much exposure to commercial equipment. Surprisingly little. It's which is a bit of a limitation because I don't know necessarily how the professionals do things. So I'm kind of reinventing things. Matt Richard asked, how do you cope with voltage drop over thin cables with passive PoE, or is it not really a problem? I run a combination of passive PoE, and by that I mean just injecting like 12 volts onto the wire. I use 12 volts for all of my passive stuff, and 802.3 AF, which is active PoE, which runs at 48 volts. So a long time ago I did a video where I talked about voltage drop and PoE, and I showed some calculations of the advantage of 48 volt PoE. It comes down to the same issue as with transmission power lines. The reason that we don't have the main transmission lines running at low voltages is that to get the same amount of power through, you need more current, because basically you multiply volts by amps and you get watts, and if you run at a lower voltage you need more current, and to carry more current you need a bigger conductor, so it's a trade-off. You can use thinner wires with higher voltage and you get less drop, and there's the whole I squared R law and other things I won't get into right now. So getting back to Matt's question, I generally don't have a problem because the things that I'm feeding with PoE are usually running at a lower voltage than that. So typically what will happen is that I'll have something like a 5-volt regulator on the board that I'm powering, and I'm not pulling a huge amount of current. It'll be things like sensors or maybe indicators or smallish devices. I'm not trying to do things like run PoE lighting using DIY PoE. So PoE lighting is a whole other subject. There's been a long conversation about that on the Discord, and I won't get into it right now. Maybe that's for another time. So I'm not really trying to run high power loads over PoE. It's pretty much low power sensors and things. And typically the most that I will be drawing at the other end is like 5 volts at a couple of hundred milliamps. So voltage drop isn't really a problem. But I do also have 48 volt PoE running things like the Unify access points. So my Wi-Fi access points are Unify, UAP AC Pro access points, and they're powered on PoE. Now for an access point it does actually need a reasonable amount of power because it needs to be able to broadcast. So it's not pulling like in the milliwatts of region, it's pulling in the watts of power region, and those are running on proper 48 volt PoE. Alright. Now James, I touched earlier on a comment from James who talked about reliability and how your system is built to fail. Yeah, I'm not going to get into that right now, but that is a very important point. Alright, let's see what I've missed, and then I want to try to get on to showing you a couple of things. I'm going to do an update on the Ether Uno design because I'm about to send that off for fabrication. I'll show you the designs and get last minute input before I do that, but I'll just get through some of these comments first. Alright, oh yes, so Adam S said, talking about MQTT, it would be great to hear your or Andy's recommendations on MQTT structure, etc. Did you say you were going to do a video on this topic? Yes, and Andy has already followed that up and said, yes, we're working on covering MQTT, home automation devices, etc. before too long. We'll discuss choosing MQTT topics. The answer may surprise you. That sounds like a clickbait article. How could we do that? Yeah, how should you choose your MQTT topics? The answer may surprise you. Um, yes, this is something that has been brought up a number of times over the years, and the what happens is people say, should I structure my MQTT topics based on device type and then location so that I can say, show me all the temperature sensors? Or should it be based on location and then device type so I can say, show me all the data for the kitchen? And they present that as the two options. But there are more options. So yeah, Andy and I have been actually actively working on this over the last couple of weeks. As I said, Andy is the guru on this stuff, and we're going to do some some things about that in the future. And Andy has been giving me a crash lesson in Python programming as we've been working on something in relation to this. So there will be a lot more to come about that. Right now, the way my own system is working is I have a bit of a mishmash because I started off doing it one way and then I ended up mostly standardizing on the structure that Tasmota uses, even though I don't like the Tasmota topic structure, just for consistency. So things like the air quality sensor that I've been working on, I do the topic structure for that in the Tasmota sort of format. But because Andy has been helping guide me through this whole process, I came to realize that it doesn't matter. That's the trick answer. There are ways that you can make it not matter how the topics are structured. So in terms of the underlying thing at the moment, most of my topics are Tasmota sort of format, but then once they're brought into the logical environment where you're dealing with them, the topic that the data came from doesn't matter. The only question is how you discover the topics, and that is a really interesting thing that Andy has some really cool solutions to. So discoverability is really the key. I mean, when you think about it, the MQTT topic could be a random string of characters, and if you know what that random string of characters is, and you can map it to something, then it doesn't matter what the random string of characters is. Where it matters is you looking at that topic and knowing what it is. It's the human readability part of it and mapping the topics in your brain to what they are for and discovering sources of data on your network and being able to make use of it. So those are the sorts of things that Andy has been working on. And he's been working on it for a very long time, like 20 years or something. So yeah. I'm going to stop talking about that because more will follow. All right. And about failure and perception, Mike made a very good observation. We pre-prime the operators saying they will have issues for at least a few months and then it will become stable. This seems to help. Yeah, set expectations. That's a clever move. Thanks, Mike. And cable tie. Okay, so thank you, cable tie, for this reference. There are two well-known psychology factors at work: recency effect and confirmation bias. If you're interested, search for availability heuristic and Amos Tversky and Daniel Kahneman on Wikipedia. Awesome. Yes, so when I was talking about the recency of the last failure, so maybe my memory isn't so bad after all. I remembered that was that was part of the factor here. But I need to go back and look at that. That reference is really useful. Thanks, cable tie. And Julian Sermon said, do you keep swap-in spares of small, unmanaged, larger backbone switches? Yes is the answer. So what happened when IVT, my former software company, IVT, was sold off a couple of years ago, and the new owner took over, some of the staff switched to the new owner, and they disbanded the office. So we ended up pulling down what was now our data center and the office, and the new owner didn't care about most of it. So in my garage now I have a couple of full height server racks and a couple of dozen rack mount servers, plus a whole bunch of other stuff. I'm just sitting there doing absolutely nothing right now, which really sucks. It's just taking up space. But part of that is that I have a stack of rack mount switches. I don't know how many there are, but the stack is like that high, sitting in one of the racks. And they are not plugged in or turned on or anything. They're just sitting there in a rack. So if anything goes wrong, I can just reach across, grab another switch, and shove it in. So I've got random networking stuff just piled up in the garage. So yes, I do have some spares ready to go. I wish I didn't have such an excess of spares, but oh well, that's the way it is. Now in terms of things like okay, a little clarification here on terminology. Now I'm sure many of you already know about this, but the way I think about it is cold spares, warm spares, and hot spares. And this is sort of terminology that's often used in scenarios like databases and servers and routers, all sorts of areas where you have a single device that you might want to replace. Now, this is not taking into account things like load sharing groups or load balancing and that sort of thing. But a cold spare is a device that's sitting on a shelf, not plugged in, and in order to use it, you've got to plug it in and configure it and bring it back online. Warm spare is it's sitting there ready to go, configured, but not in active use. And hot spare is it's all plugged in, configured, powered up, ready to go, and you can fail over to it and have almost no downtime. And I am not very good about hot spares in my home automation system. I have in fact right now, I just recently pulled it off the wall because I was going to reuse it. For many years I've had a second Raspberry Pi running. So I've had two Raspberry Pis sitting there side by side, both running live, and well, not one of them actually actively running the house, the other one with a complete duplicate setup. So it had all of the same software installed on it. It had the configuration synchronized, so it was ready to go. I could update some IP addresses and switch to the backup device on a few minutes notice. And a little while ago, I actually pulled that one off because I had run out of Raspberry Pis and I needed it for something, and I haven't put it back. So right now, I do not have a spare setup for the main controller for my house, which is really sucky. I need to fix that. All right, so Rulish Prasad said, James and I were discussing along the idea of layering my functionality. Have two Arduinos talk directly on I2C, still have relay switch Arduinos subscribed to MQTT. You no longer rely on the network. And Andy asked about, Andy said, what about the distance limitations of I2C? All right, so I didn't comment on it. I saw this discussion happening in Discord, but this week I've been mostly offline and I really need to catch up on stuff on Discord. And I thought that was really interesting. So the summary here, based on, hopefully I get this right, based on what I saw on the discussion in Discord, is at the moment the way my system works is that I have an output controller which controls the relays in the switchboard, which is on the network and subscribed to MQTT. Then I've got a switch controller which reads all of the switches and it publishes to MQTT. And then I've got the logic that links them together. So if the network fails, the messages from the switch from switches don't make it to the lights. It's broken in the middle. Now, I think what Rulesh is suggesting is integrating the output controller and the input controller into a single device so that the device can read the light switches and it can use I2C to control the output actuator using, could be something like MCP 23017s to address the relays. And so that means that it is no longer reliant on the network operating. It could be totally disconnected from the network and it's a standalone single device that reads the light switches and then sends the commands to the outputs. You can still take advantage of MQTT integration because the device itself can subscribe and publish. It can be connected to a network, and then you can have a larger part of the automation system that sends messages to it or gets updates from it. But it can operate in isolation with zero network connectivity. I hope I've described that correctly. Now, the summary of my opinion of that is, yes, that is generally a good idea for smaller installations. The problem with mine, for example, is that mine is split across multiple switchboards, and so what would happen is that I would end up with local control. It would still have advantages, because what would happen is that it would compartmentalize failure. If, for example, I wanted a switch, okay, so as an example, I have lights on my back veranda on the back of the house. So where I am in the lab right now, I walk along the back veranda to get into the house. I can control that from she who shall not be named, or from a light switch at this end, and there is a light switch at the other end in the house. The switch at the other end goes to the far switchboard, the switch at this end goes to the close switchboard. So they are not connected to the same switchboard, they are connected to different controllers entirely, and it relies on the network to send the commands between them. So if I was using the architecture that Rulesh is suggesting, and the network failed, what happened is that one of those light switches would continue working, the one at the other end would stop working because the network link between it would not be working. So the failure would be compartmentalized, but you could still control things. So that does have an advantage. So yeah, I think it's an interesting idea. And I'm pretty sure that Rulesh is well advanced on putting the system together. So that is quite cool. Hopefully that works out well. I'm very interested to see how this goes. Thank you very much for that suggestion, Rulesh. Oh, here is a very interesting question. Dr. Reality 1 said, what sort of home alarm system do you use that complies with insurance company requirements and integrate with Home Assistant / automation? And David Cole replied and said a standalone one with in connectivity that home automation has deciphered, i.e. a paradox with modules and MQTT bridging software. And Andrew Gordon said, I have a paradox alarm system with a third-party reverse-engineered Python script that bridges its IP interface to MQTT. So, ooh, this is a can of worms. Now, I have gone on rants in the past about over-regulation in Australia. Excuse me. Trying not to cough straight into the microphone. Now, in Australia, the security industry is very heavily regulated, and it is illegal to install an alarm system or a security system unless you have the correct certification. Now, people outside of Australia right now probably heard me say that and thought, What did that sentence even mean? That doesn't make any sense. Why would you need certification to install a security system? That's Australia. And there is an upside to it. So the thing is that in Australia, we have a security industry that has a combination of very, very good professionals who know their stuff, take it seriously, and we have fly-by-nighters who don't really know what they're doing and are just trying to sell the cheapest stuff and don't care about doing the job properly. And part of the reason for the regulation is to try to keep the level of professionalism up. Now, one of the side effects of this is the issue of things like modifying alarm systems and building your own alarm systems. So I'm in a private Facebook group which is specifically for it's for posts showing crappy security system installations and the things that professionals come across that make them go, oh, what the hell were they thinking? You know, you see stuff that is just baffles your mind, and it was obviously done by someone that has no clue what they're doing. Now, I am not a security professional, and I claim no expertise in that. I've done a little bit in the past with things like end-of-line sensing. So I've designed some boards like the IOSec 8, which is the 8-channel security sensor interface, which implements end-of-line sensing, and so it can detect people trying to tamper with the lines, like shorting the lines or cutting the lines or whatever. And but I don't claim to be a professional security cabler or have great knowledge in that. And what was interesting is that there is a project that came up a little while ago, and I haven't seen it much recently, but I used to see Facebook ads for it everywhere, which was a retrofit security system interface. And yeah, as I said, it's a while since I've seen it. I'm trying to remember what it did. I think it might have been based on an ESP 8266 or ESP32 or something, and it was being promoted as rip out your existing security system, put this in its place, do it yourself, and you'll have an online connected security system. And it was very much aimed at the DIY market, and it got a lot of there was a lot of blowback within the professional security installer industry. And it's the sort of thing that in other countries, you know, nobody would even think twice about. But in Australia, it was seen as potentially dangerous and opening the way for people who don't know what they're doing to be installing security systems when they really shouldn't. So, I don't really want to get into this too much. What is the time? It's nearly an hour, and I still want to show you some projects. So, let me see. So Ragnar said, I'm getting a new apartment next week, possibly has no neutral wire on lights and no grounding on wall plugs. Should I change all? Ooh. Now, the big question here is, do you own the apartment? And this brings up a really interesting question. I want to make this a topic for a future live stream. But, okay, so here's some homework for you all. I want suggestions in relation to this. In the past, like a few live streams ago, I did one where the topic was, you're building a new house and you want to pre-cable. What things should you keep in mind? Like, how do you future-proof your new home construction for automation? Now, the counterpoint to that, oh, Ragnar said, I do own it. Awesome. So you've got some more flexibility there. But it's still a retrofit job. And So the counterpoint to that other topic is you have an existing structure. It might have old wiring, no neutral at the light switches, and you want to retrofit to that. So how do you go about it? Now the thing is that is a really, really big topic, and it's not something that I can really answer in a few minutes here. And part of it comes down to the number of scenarios. Now there are certain common scenarios that you can deal with. So it's that classic thing where some 80% of the problems will fall within a certain scope and can be solved in a certain way. And then the remaining 20% is what makes you really scratch your head and go, how the hell am I going to do this? So put aside the hardest things, look for the easy things. The easy things are generally approaches like using something like a Sonoff Mini or a Shelly and mounting it inside the ceiling near the light fitting where you have both active and neutral available, and running just the switch wire down to the switch location, which is being an input to the automation device. It's not switching mains anymore. You convert it over so that it's just switching the input. So then you have logical control over your light both via the network from your automation system, and the switch on the wall is a logical input as well. Now that one thing will get you through probably 80% of the lighting of your lighting retrofit. Now there are situations where that is not necessarily easy. You might not have access into the ceiling space. You might have cabling that goes through, like you might have a multi-level dwelling and the cable goes through a gap between your ceiling and the floor of the next apartment above you, and you just can't get in there. So there are things that you can do with that, like accessing through the location of the light fitting and putting something like a Sonoff Mini or a Shelly behind the light fitting by taking the light fitting off, maybe enlarge the hole a little bit so you got room, and put the device up there. But then there's the issue of how do you run the wiring down to the light switch, and this is the sort of thing that we could talk about for a very long time, about many of these different sorts of scenarios. So if you are interested in retrofitting, please jump on Discord and we should talk about that and maybe come up with some ideas. And then in a future live stream, we can have one where the whole topic is nothing but retrofitting and solving these sorts of problems. All right. Regarding the security system regulation, Mike O'Connor said Australia has a lot of cartels. Yes, it does. Dr. Reality One said the UK is not much different. Yeah, and Andrew Gordon said New Zealand has the nice balance, I think, where you can do your own stuff but can't do it for others for payment. Yeah, that is actually a really interesting observation, and I think I might have addressed that in my rant ages ago about Australia being the worst country in the world for DIY home automation, because it's really interesting to look at Australia and New Zealand. It's not often that you get a direct apples to apples comparison. Usually what you're looking at is something like Australia compared to the US or the UK, and the regulations are totally different, the voltages are different, the mechanicals are different, the standards are different. So you can't really say, oh, this country has fewer deaths by electrocution because the regulations are better, because there are other factors that are involved. It's that classic thing of if you change two things and then you get a different result, you don't know which of those two things you changed that actually made the result. And that can be complex interrelated factors. But Australia and New Zealand have the exact same common standards for most electrical things. And that's why when you're looking at the standards numbers, it'll be AU/NZ dash whatever, and it will be the standards number. We have the same voltage, we have the same mechanicals, we have the same standards in terms of insulation and the way things need to be structured. So physically, what is in the wall in Australia and New Zealand is the same thing. The difference is who is allowed to do it. And that's really interesting because it does actually allow you to do a direct comparison and say Australia, with its extreme regulation, and no one is allowed to touch anything unless you've done a full electrical apprenticeship, versus New Zealand, where a homeowner is allowed to do their own electrical work, but you can't, you can't work as an electrician and go and charge other people to do it to their houses. So you can't become a professional electrician, but if you want to do something in your own house, you can. Those are two very different things. And yeah, so I think Andrew is right that New Zealand has the correct balance. I look at the way New Zealand does it and I wish that Australia was the same. What you don't want is cowboys who think they can become an electrician just because they've wired up something in their own house and then they start selling their services and doing unsafe installations around the place. And that is prevented in both Australia and New Zealand because you can't offer your services for a fee and become a professional electrician without going through the apprenticeship and actually knowing what you're doing. But in New Zealand, they have that slight relaxation where if you want to do things for your own use, then you're allowed to. Now, the justification in Australia for not allowing that is a situation like, okay, so someone did something in their own house because it's legal and then they sold the house. And now the person who's bought the house is having to deal with something that was done by the previous owner. But there are ways to solve that problem as well. There are electrical inspections and all sorts of things that can be done at the time that a home is sold. So, yeah, I think New Zealand has struck the right balance there. That's my personal opinion. Okay, so connected.io. I think this might be the one that I was trying to remember. So a number of people have pointed out connected.io. Is this it? I've just gone to the site and it doesn't look super familiar. Installs in place of your existing system's motherboard. Yeah, I think this might be it. So this device, oh yeah, looks like it's got an ESP32. Yeah, this is the board I was thinking of. So connected.io, I will drop this URL in the chat just in case anyone is interested. So this is a little board, and the idea is that if you've already got an existing alarm system, you will have a panel somewhere in your house. So it's a steel box. Inside will be the main controller, and it's got a link out to a keypad. It's got a power supply with a battery backup, and it's got links to all of your sensors. What you can do is remove the original control board that's inside that, replace it with this connected I/O board, and now you have total control over your alarm system, and you can integrate it with your home automation system. So yeah, that got a lot of promotion, I don't know, maybe a year ago, could be longer, and a lot of backlash in the professional security installer industry. A lot of professionals did not like the idea that all of a sudden people were going to be installing their own alarm panels. Take that for what you may. All right, now I am going to quickly jump into something else. Oh, hang on. I had another question. So another question from a Patreon. So Daryl said, are there any projects that I've abandoned and why? And any projects I have ideas for but are too hard, or ideas for a community project? I'm I really do want to get on to showing these other projects, but I'm just going to very quickly answer this one. I have a huge number of projects that I've deferred. I wouldn't say abandoned. I almost never abandon a project. Maybe that's just me lying to myself. If the reality is that I'm not going to get back to it, is it abandoned? Probably. Okay, a classic one. When I saw this question, the one that sprang to my mind as something that I keep kicking myself that I haven't followed up on is the under-house access for the robot lawnmower so that it can go through to the front yard. Now, it's a few years since I've really talked about this, but I have a robot lawnmower and it's awesome. I love it. It's a Husqvarna Automower 430 and it mows every day. The grass never grows up because it just keeps being trimmed, whiskers taken off the top every day. And I want to be able to have it go from the backyard to the front yard to do that lawn as well, and then come back to the backyard to its docking station for recharging. When when the Automower was installed, my plan was to have a channel or a tunnel going under my house because there is no real way to get from the backyard to the front yard. We have a dog that we leave in the backyard sometimes and we don't want her to be able to escape. And at the moment we don't have a gate on our main front entrance, and we don't have a gate on our driveway. So if she gets through to the front, then she's off down the street and goodbye Bonnie. And so what I need to be able to do is have the mower go from the backyard to the front yard, but not have Bonnie get through. So the issue is having a gate or a door that will open as the mower approaches so that it can go under the house and then close so that the dog can't get out. And it's something that I've been wanting to do for years now, and I just haven't got to it. I even got so far as buying some of the equipment, like the actuators to make the door move, and I have that stuff sitting in a box ready to go and haven't got back to it. So that is, of all the projects that I failed to follow through on, that's probably the one that I regret the most, but I don't claim it as abandoned. I'm still going to get to it. Just not this week. Yeah, so I've been thinking more about it. What I had been thinking was that I would have a door that was hinged from the top and an actuator. So this is like around the baseboard of the house, and I'd have the guide wires for the mower that come in to that point, and then when the mower approaches it, the system would lift the door so the mower can go underneath, and then the door would close again, and that way the mower could get through but the dog couldn't. But the thing is that the more I think about it, the more I think it might just be easier to leave it as an open hole because it's not really that high. The mower, I should measure it. The mower is actually surprisingly big. Like when the Husqvarna people turned up to do the installation and they pulled it out of the box, I was like, what, that thing's enormous. I was expecting, I suppose because in my head I've been thinking about automatic vacuum cleaners, and you know, they're small. And the Husqvarna Automower is like this long and it's quite big. But it's not really that high. I'm just trying to take a guess now. It's probably 300 millimeters high, maybe. So if I made a slot in the baseboards that was 300 millimeters high and wide enough for the mower, I could possibly get away with just leaving it open as a hole that goes through into the underhouse area. Bonnie would probably be able to get through it if she wanted to, but I think maybe the better solution is to put a front gate on, and that way, even if she is in the front yard, she can't escape, and then the problem goes away. And aesthetically, I think it would be okay because the location where I could put it is in a part of the garden that's sort of a bit out of sight, so having a hole in the baseboards big enough for the mower to go through, I don't think will be a huge problem. And I could even have something that hangs from it, but it's not actively actuated. Like I could get a sheet of like black rubber or something and have it connected at the top, so the mower can just push through it and the flap just moves out of the way. And that way, at least aesthetically, it doesn't look like there's a big hole there. All right, so other parts of Daryl's question. Are there any other projects for ideas that are too hard? No, not really. I suppose maybe I'm a bit naive and I think that I can build anything. So I suppose my approach is, if I want to build something, I know when I start the project, I don't know how to do it. But I just assume that I can figure it out along the way. That's my approach. I don't begin projects as an expert in whatever it is the project is. I just figure... Scott just said, just put something in the tunnel that'll scare the heck out of the dog. Yeah. I don't know what. Oh, and Dodgy Brothers suggested, wouldn't a door that slides sideways be better? Yeah, I kind of thought about that. You could have a door that is on tracks, like a sliding driveway door. But I was thinking in terms of fail-safe. If it's lifted, it's probably easier to make it in a way that if something hits it, it will move out of the way. For example, if it was just hinged and it sat vertically by gravity, you could have a drawstring at the bottom going up to a motor with a little spool on it. So to open it, the motor runs and it spools up the string and lifts it. But it means that if something hits it, it's just going to move out of the way. I don't know. I just thought that doing something that hung would be easier than doing something that slides. But maybe not. All right. So I'm going to change gears now and give you a quick look at the Ether Uno design as it currently stands. Let's see what is on the desktop. We've got the Ether Uno. So I showed this last week on the live stream and I've made a few changes. Oh, Maix said, maybe a dog treat has to be dropped when the robot crosses into the tunnel so the dog is distracted. Yes. Yeah, when it's going to open, you drop the treat over at the far end of the yard. So many funny suggestions. Okay, so on the live stream last week, one of the major questions was about the USB to serial converter. And in this, I've switched it for a CP2102N. It did have the ATmega 16U2 sitting up here in the corner. Let's go over to the schematic. And it's dramatically simplified things. I like simple. All of a sudden there are gaps on the PCB that just weren't there before. So what we have here is the ATmega 328 microcontroller, which is the main processor running the board. I want this to be Arduino Uno compatible, so that hasn't really changed. If you look at this part of the schematic, there is absolutely nothing surprising about it whatsoever. It's an ATmega, it's got a crystal over on here, it's got the reset pin. Over on this side, we've got the I/O pins that go to the Arduino headers. We've got D13 using the MOSFET to switch the LED, same as before, so that D13 can still be used as a digital input if you want to. It's not being biased by the LED. We have the serial comms coming in through a couple of 1K resistors, which are probably just a bit of paranoia, but they are there anyway. And that is the link from the USB to serial converter. So this is the part that has changed totally since last week. Previously there was the ATmega 16U2 here, and that meant that it needed a crystal and the other standard supporting parts you need to make it work properly. Things like the ATmega parts do work from an internal oscillator, but to act as a USB to serial converter, it needs a more accurate clock. it can't maintain the timing necessary to do USB comms if it's running off its internal oscillator. So the 16U2 had an external crystal. What we've got here, there's the VBus reference, and we've got TX and RX LEDs, which are connected to GPIOs on the USB to serial converter. So this is the Scilab's CP2102N, and this is a dedicated USB to serial converter chip, which means that it'll work out of the box. One of the advantages of this is that it means that in manufacturing, we don't have to flash this with firmware. We were using firmware based on Lufa, and so this chip can just go straight down on the board and it will work. The one caveat is that it needs to have a couple of options enabled so that GPIO 0 and GPIO 1 are the TX LED and RX LED respectively. Until those options are set, these LEDs won't do anything. So in production, what will have to happen is that when these boards come off the production line, they will need to have the bootloader put onto the main processor. They will also need the Scilab's, I can't remember what it's called, the Scilab's management software, whatever it is, something, Simplicity Studio, that's it. So there will need to be a computer in the factory with Simplicity Studio running, and they'll need to plug it into USB and click go, and then it will load the profile, which will enable these. So I just saw that Sion, Unexpected Make, just said, yay for the CP2102N, how are you going to one-time program it? Because of the volumes that I'm talking about, now it is possible to buy things like the CP2102N with options pre-enabled from the factory, but the volumes that I deal with are small enough that Silicon Labs don't really want to talk to me. I mean, these boards I get done typically in batches of 144 at a time. Sometimes if I'm really cashed up and I feel like stocking up, I'll get 288 done at a time, but I'm not doing thousands. So that will just become part of the process of the end of line testing and manufacturing. I've seen a couple of comments in here about memory in the 2560. I'll get back to that. I've noticed that comment, James. So what else is there? Nothing much else interesting. Oh, there are little protection Zenas here. So that's for protection on the data lines. Oh, and one thing to note here is that I've got 5.1K resistors on the CC1 and CC2 lines. This is a USB-C. This is a USB-C connector, and in order to tell other devices the power mode of our device, we need to put specific resistances on those lines. I don't even know what CC stands for. Probably charge current or something. I don't know. But if you put a 5.1K resistor to ground on that pin, it tells the device that you're connected to that you are an old style USB device. You want 5 volts and 500 milliamps, which is the maximum spec under the old USB 2.1 or whatever that spec was. I don't remember. USB specs are ridiculous. Oh, and some of you might remember that there was the furor that came up when the new Raspberry Pi 4, I think it was, came out with USB-C on it, and it couldn't be powered by anything except an official Raspberry Pi power supply, and that's because they did something here. What they actually did was this. I'm going to undo this in a second, but I'm going to delete one of these resistors, and they just bonded both of the lines. I don't care what it's called. They just bonded both of these lines together, CC1 and CC2, through a single 5.1K resistor to ground. Now, that works if you plug into a a power supply that is not doing proper negotiation of the charge voltage, etc. So what happened was that in their initial testing, they built prototypes, etc., and it worked. They could power the Raspberry Pi fine, and then people started buying them. So they went into production, they got out into the world, and people started plugging them into different types of power supplies. I can't remember which ones had the problem. It might have been like Apple USB-C power supplies, that actually honor the negotiation there. They look at this and they see CC1 and CC2 tied together through a 5.1K resistor, and it's not the proper they see that the device is not responding with the proper indication on those two pins, and so they refuse to supply power to it. And so the result was that Raspberry Pis went out that could not be powered unless you powered them from certain types of power supply. So what they should have done, I'm just going to, oops, no, that's not what I wanted. Where's undo? That. So what they should have done is that. Yeah, that was a bit of a red-faced moment for Raspberry Pi Foundation. Anyway, this way we can plug it into whatever we want to and it will be powered from it. Nothing else interesting there, so I'll move on. I could spend way too long talking about this, and I'm already at 11:22. Power supply, I've got the linear power supply in there. Oh yeah, so the summary is on this, what I did was I removed the old 16U2, put in a dedicated USB to serial converter. That's the major change since last week. Then power supply, I've got the 5-volt linear regulator feeding into a 3.3 volt linear regulator, dual footprint, as I explained last week. We've got the power source selection here, so it prioritizes DC in. We've got the decoupling for the WISNet chip. So we've got 1.2 volt and 3.3 volt rails on the WISNet chip. And the different number of capacitors is because there is one capacitor per power pin for each of those rails. So on the 1V2D power rail, there are 4 power pins, and on the 3V3A power rail, there are 2 power pins. So I've matched the number of capacitors, and that means that I can put a capacitor right at every power pin, just for maximum durability. Ethernet interface, I don't think anything really has changed in here, so there's nothing too exciting to look at. We looked at this last week. It's got the WISNet W6100 on it. It has a mode input here, so pin mod 0 is going to this thing here, and it's being pulled low through a 10K resistor to ground, and that defaults it to running in W6100 mode with IPv6 enabled. And there is a solder jumper. If you put a solder bridge across that, it pulls mod 0 high, which puts it into backward compatibility mode of W5500 mode. And it disables IPv6 and all those extra registers and things. Micro SD, power supply. That is the dedicated power supply for the. Sorry. That is. I need to fix that. That really had me boggled for a second. That is not 3.3 volt power supply. That is MAC address ROM. That is the little MCP24AA025E48, which gives you a 48-bit unique MAC address on the board, and that's it. So nothing really else interesting to look at on the schematic. The board up in the top left corner here has a whole lot less stuff on it. So this area up here is where the 16U2 used to be, and it used to have a big HC49 US style crystal sitting here taking up a chunk of board space. It was all very cramped, and now you can, like the old version was a whole mess of vias around there. It was lots of little traces all trying to get through. And now we've got copper to spare. There's a big chunk of room over there. Up here, the large through-hole crystal has been replaced by the little surface mount crystal, and same over here. So this is the crystal for the WISNet chip. It needs a 25 megahertz crystal. I'm going to change that. My computer is being very laggy at the moment. Rendering is very slow. So we've got the linear regulators down the bottom here, 5 volt regulator, dual footprint 3.3 volt regulator, and let's switch over to the 3D view. So this is where it currently is. There are still a couple of little things I need to fix on the silk screen, but I think it is about ready for me to order some PCBs to do some testing. So you can see, for example, I've screwed up here. I've got the silk screen for the URL overlapping with the pad, and you can also see in the 3D view it's got all the part designators, R14, R15, etc. Those will not be there on the final thing. That's just the way that Fusion 360 renders it. It shows that layer, even though I don't include that layer when I generate the Gerbers. Is it Gerbers or Gerbers? I've never known how to pronounce that. I always say Gerbers, but maybe it's Gerbers. It was named after the guy who invented it, so maybe I should check on how his name is pronounced. I just discovered only just this week that there was a guy, he was I might be misremembering details. I always tell stories badly. He was a German guy who survived a concentration camp, and I think he had 2 sisters who both died in the concentration camp. He survived and then went on to invent a huge number of things. Like he invented, he started a company that made plotters and other devices, like through the 1950s, 1960s, and the file format, so Gerber or Gerber file format, is based on his name, because the format used for PCB track layout is based on the way plotters were done, like ink pen plotters, way back in the 1950s. Anyway, I probably told that story totally wrong, and now you are more stupid for having heard me say that and say it incorrectly. So yeah, this is where it's up to. I think it's basically ready to order some boards. What I'm going to do is just order the minimum number of boards from all PCB. I'll probably get like 5. I think that's the smallest number they'll do. And then I'll just, I will just hand assemble one, see if it works, find all the mistakes I made. But yeah, there's so much more space here. I didn't go quite as far as ripping up every single track and just rerouting the entire board, but most of it has been rerouted. Pretty much every track has been touched in some way. And the other thing is that when I was doing this originally, like the early versions of the Ether 10, I was doing everything on an imperial grid, and a few years ago I switched over to using metric grid for all my PCBs. It was a little bit weird because 0.1 inch has been the standard grid size for PCBs for many, many decades, and even though component footprints and things are usually given in metric sizes, it's still pretty common for people to use imperial dimensions. Like they'll talk about a 10 thou track, which is 0.01 of an inch or whatever it is, and so people use thou. I hate that term. That they'll use thou or mil, and I really hate mil because it's confusing with millimeter, but a mil is an imperial measurement. So it's pretty normal to have PCBs where the board dimensions and the track width and part spacing and everything is based on an imperial grid, and the footprints for all the parts are metric. But quite a few years ago now, I switched over to using 100% metric. So all of my boards are done that way. So instead of using like a 0.01 inch track, I'll use a 0.254 millimeter track, that sort of thing. So a lot of these tracks have been rerouted on a metric grid, and there are still some ugly things that I need to clean up. It's funny how I can spend so long just polishing boards. For example, what will happen is that I'll come into the 3D view like this, and I will zoom in on here, and I will think, that's ugly. I don't like the way this little bit of the dogleg of the track here comes up, and it doesn't match here, and then we've got two right angles, like with that T intersection. That's not very nice. So maybe I'll take that little bit of track and I'll push it a bit so that it starts here and then it comes up to here. And then I'll wander along the board a little bit more and find something else and think, I need to move that. Move it like a millimeter this way. It'll just look better. And I end up falling into this trap where I'm just sitting there pushing tracks around and tweaking angles and trying to improve things. And it really doesn't make any difference. It's at the point of diminishing returns by then. So yeah, at some point I need to discipline myself and just say, stop, just generate the Gerbers, like run DRC, do your pre-production checklist, generate the Gerbers, and move on with your life. Now, I saw a comment there. James O'Gorman, no, was it James? No, someone asked about 3D mouse. Yes, James said, what 3D mouse do you use with Fusion? I have a 3D connection and it doesn't work with Fusion. I'm using this one. It's a 3D connection space mouse. And I love this thing. This was given to me by Simon from T-Rex Water Trucks. He bought it because he uses Autodesk something for all of his 3D design, and he tried using it and didn't really like it. It had been sitting in a drawer, and I was looking around for 3D mice, and Simon said, hey, take this one, try it. And then he said, you can keep it. So it was extremely generous. Thanks, Simon. So for people who haven't seen these before, this is, in fact, this ties into a project. It's already 11:30. Like, my perception for what I was going to do today is totally skewed. I was going to be showing you the zero deflection joystick that I've just been working on with Chris, and this really ties into the zero deflection joystick. So the idea is that you use this as a mouse, but you don't move it around. All you do is apply force on it, and it supports many, many axes. I can't actually remember how many, but with this, so what you're seeing on the screen right now is Fusion 360 being controlled by this. So I can move this. Now, if I grab this and twist it like a knob, it'll rotate in one, so that's one axis. I can go left and right. If I roll it backwards and forwards like this, it rolls the object backwards and forwards. And instead of rolling it, so backwards and forwards can be a rolling motion, or it can be a sliding motion. So if I push it away from me without rolling it, the thing gets further away, and if I pull it towards me, it comes back towards me. And similarly on the sideways, I can roll it left and right, so I can roll the object left and right, or I can slide it left and right. And I can also lift it and push it down. So if I push it down, it moves down that way. If I lift it up, it moves that way. So the result is that with your hand on this, it's almost like you are grasping that object in space and you are able to manipulate it. So what I typically do when I'm using Fusion 360, you can't see my bench right now, but what I do is I have my left hand on the space mouse. My right hand I have on a trackball. I actually don't use a mouse at all on my computer. So I have a trackball on my right hand, which I'm controlling there, and then I can right click to get to the Fusion 360 menu. I can left click obviously, so I can move the cursor with my right hand and I can move the object with my left hand. So what I can do, for example, is if I wanted to manipulate something, like say I can spin the object, bring it in here, and then with my left hand, with my right hand, I can click on this and do different things with the cursor. So it gives a lot of control. Now this is being a little bit jerky at the moment. It's not that smooth. You can see that it's sort of stuttering as it moves. My computer is not the fastest thing in the world. It's an iMac. It was a decent iMac when I got it. It's a 2013 model with an i7 processor, and I think it's got 32 gig of RAM. So it's pretty decent, but the graphics driver lets it down. Its video card is not card. It's not a card, but you know what I mean. Its video chipset is not the fastest thing in the world, but it gets really bad when I'm live streaming, because OBS is currently capturing my stream and then encoding it and then pushing it up to YouTube. Normally, this is much smoother, even on my computer. You can see it sort of juddering a little bit and it's being a bit slow. But, I can move this object around and spin it, make it do whatever I want to do. Zoom in and inspect things. Sorry, I'm probably making you seasick. But yeah, I use the 3D Connection Space Mouse for that, and I love it. It's awesome. Okay. Oh, interesting question. So, Sion said, ROHS compliant. Do you actually get your board certified, or just adding based on your manufacturing requirements? That is a really interesting question. So, for those of you who don't know, what Sion is referring to is down here on the board. It says ROHS with a tick. Now, ROHS stands for Restriction on Hazardous Substances, and it's an European Union directive that came in a long time ago, something like 15 or 20 years ago, and it is designed to reduce the amount of hazardous material that is in consumer goods, both in terms of how the consumer interacts with it. You don't want things like lead used, for example, on a device that someone is going to be handling directly, because they could end up with lead poisoning. So, lead paint is a classic example. Now, with something like a PCB, because the PCB is normally enclosed inside a device, if I was making a consumer product and I had lead solder on the PCB, then the consumer is probably not going to be exposed to the lead because it's inside the enclosure. But the other consideration is in disposal. Because typically consumer goods end up being thrown in the rubbish. They often don't go to electronics recycling. They just go into general waste, and then they end up going down to the local landfill. They get crushed and water runs over it, and whatever materials are in the device end up in the water. It just ends up, flowing out into the groundwater and potentially contaminating things, which is why you shouldn't do things like put batteries into general rubbish, because the very nasty chemicals in the batteries can end up in the groundwater. And so ROHS is a directive related to what materials are allowed to be used in consumer products. Now, what Sion is asking is whether my stuff is actually certified, and the answer is no. Now, there is a page on, let me see if I can bring this up. On the Freetronic site. I can't remember if I've put this on the SuperHouse site as well. I probably should. ROHS certification. Alrighty. I'll bring this over to this and zoom. So this is a disclaimer page that I've got on the Freetronic site, and Oh, okay. So July 1st, 2006. So 14 years ago, just over 14 years ago, um, this agreement came into effect. And what it means is that if you want to sell a consumer product into the European Union, you need to comply with this ROHS restriction. And sorry, I'm losing my train of thought here. But there are exemptions. There are exemptions if, for example, you're not making a consumer good. If you're making a device that is used for prototyping or that is a component that it might be used in larger things, it's the final device that needs to be certified, and that certification is based on everything that it contains. So essentially what I do is manufacture everything to comply with the regulations, like using lead-free solder and all those sorts of things, but without getting the certification. So if if someone wanted to build a consumer product and they wanted to buy boards from me and then incorporate those boards into their consumer product, they would need to get the final product certified, but that is up to them to get the certification. Unfortunately, it's not really economically viable for me to go through the whole legal certification and provide certificates that say yes, we comply, etc. It's not practical. So, here we go. Our products fall under the category of monitoring and control and are exempt from requiring compliance. And there's more information on there. So if someone wants to know more about ROHS, I'm not going to get into this more right now, but that was a very good point that Sion brought up. So where can I drop this? I've lost track of all my screens. Where on earth is the chat window? I think it must be under here somewhere. No. Where is it? If I can, I will drop that URL into it. That one. Okay. So this is just the page on the Freetronics site, which has got the disclaimer related to ROHS. But for people that are interested in learning more about what that actually means, the bottom of that page, as you just saw, it's got a couple of links to the directive. I'll bring this back over. Here you go. There's a link to the Wikipedia page and the actual EU directive. Hopefully those links still work. I haven't checked them for a long time. I assume the Wikipedia page will work, and that explains all of the background to that. So yeah, good catch, Sion. Thanks for mentioning that one. Now, 11:44. I was going to spend nearly 2 hours today showing things like the Zero Stick and other cool projects that I've been working on, and I haven't even got to them, and I don't think I'm going to. But there were questions earlier about oh yes, as Sion said, Tiny Pico is 100% ROHS compliant, but I don't bother certifying or even showing the branding. Yeah. Yes. So it used to be that I would get questions every now and then. In the early days, I would get email from someone at a company saying, I have bought your Freetronics 11 board and I'm going to build it into my product. Please supply all the certificates of compliance and other documentation relating to ROHS and CTIC. And I'd have to say, sorry, we can't supply that. But that's just the way it is. Alrighty. Alright. So I'm going to get back to a couple of questions here, throwbacks in relation to the Ether Uno. There was a question about from James about doing this with an ATmega 2560. So I assume then, James, you have not seen the Ether Mega, which is the same thing with an Ether Mega 2560. I wonder if it's even here. It might be. No, I'm going to switch back to Eagle and open save. Yes. And open the Ether Mega. Oh, go away, you manage library updates. So this is the Ether Mega, which is an Arduino Mega with Ethernet. Now this particular one is not updated. Now the one that I showed. So what you're seeing on the screen there, or is it? Which one is this? I can't even remember. Maybe this is the updated one. This could be the version. Yeah, I think it is. This is the version with the updated WISNet chip on it that I was doing a while ago. Oh no, it's not. It doesn't have USB-C. This is old. This is the Ether Mega, not the Ether Mega 2. So this is the version that is currently in production. We've made many of these boards. So it's an Arduino Mega with Ethernet and PoE, etc., which gives you more memory for doing things like having libraries in it. Now there was a comment that the Ethernet library and MQTT on the Ether 10, there isn't much room left for a program. Yeah, that's true. Now, one of the boards that I did some prototyping on a little while ago, no, I'll just quickly wrap this up. So there is the Ether Mega. If you want a board which is similar but has a lot more memory, and if I jump back to front camera for a second, this is what I showed last week. So it's the Ether Mega 2. This was 2 years ago. I made this. It's a version of the Ether Mega, but with USB-C, etc. And it's got a switch mode power supply. Okay, so James said, I know the Ether Mega, but don't need the pins. All right. Then that's getting onto something that I would like to show. But I'm not sure if this project is ever going to go ahead. It might. Let me see, where is it? There's a project called the Baby Bear. And I think I have a feeling that my Baby Bear prototypes are sitting in the back room, but give me a second to have a look. And it solves the whole problem of lack of memory on the Uno. No, it's not out there. Where did I put the Baby Bear? Now, while I'm randomly looking around, oh, here it is. So, the whole backstory to this. The Baby Bear is a spin-off project from a crowdfunding project that I did a few years ago. I helped out, it wasn't my project directly, called the Goldilocks. And the idea was that the Goldilocks board, it was named that because it was not too hot, not too cold, it was just right. It was a board that had the right balance of features for running FreeRTOS. In fact, let me find some Goldilocks boards. I'm sure I've got some down here somewhere. Goldilocks, yep. bashing around all over the place. So this is a Goldilocks board, which is almost the same format as an Uno, like in terms of the headers and things. And when is this from? This is, I don't know. This is many years ago now. And you can see on the silk screen here, there is this black strip down the edge. That's because this board, in fact you can see it more clearly on the back, the golden part of the board is the outline of the standard size of a regular Arduino Uno. And the black part is an extension. So this is slightly longer than a regular Uno, and that was to allow some extra pins. It's got the extra 2 analog inputs on here. So this header is the same length as the analog input header on a Mega. It's 8 instead of 6. And the major difference, and there are lots of extra things on this board, the major difference is that it's got an 18 mega, what processor was this? 644, I think. Let's see. We're going to take a little detour into Goldilocks territory. I've got to find it. Just finding G in my list of projects is hard. Goldilocks. Load. Alright, switching to desktop again. So this is the Goldilocks board that I was just waving around in front of the camera. And it is a 4-layer board because there are a lot of extra signals on there. And the processor is, that's right, it's a 1284p. Of course it is. So 18 mega 1284p is, it's got the same basic core as an 18 mega 328, which means that it's compatible with it, but it has bucket loads more memory, which is really nice when you're doing something like using FreeRTOS. And this particular board I designed in partnership with Philip Stevens, who at the time was the AVR maintainer for FreeRTOS. And he specifically wanted a board that did just what he wanted as the ideal FreeRTOS AVR platform. And this is what we came up with. So he told me what he wanted and drove all of the specs, and then I did all the board design. So I don't even know when this was. Let's see. Schematic. There should be a date in the schematic somewhere. Where are we? 2013. Yeah, so this became a crowdfunding project. It was done through, who was it? Indiegogo, I think? Maybe? I don't know. But anyway, yeah, it did pretty well as a crowdfunding project. Exceeded its goals, and yeah. But the thing is that this had basically everything in it. So the way Philip saw this board is that it was the ideal balance, and that's why it was called Goldilocks. He wanted to have just enough and not too much. But in my opinion, it has too much. Now, for example, there are isolation cut track jumpers on every single header. So on D2, for example, this is the D2 header, and then there is the D2 possible. Cool. So yeah, so Andy has pointed out that it is on possible. Yes. So D2, the actual D2 pin, and then the D2 header, and it's got a cut track jumper, and so on and so on. So look at all of these cut track jumpers, these solder jumpers, and they are closed by default, but you can cut them open if you want to, which means that if you want to isolate any of the headers on the board, you can do it by cutting a little cut track jumper. Now, I think that is a very niche need. I think that's going overboard. So What else? There's a dedicated I2C header. There's JTAG. One of the other nice things about the 1284p is that you can do JTAG. So you can do debugging and all that cool stuff. It's basically like an ATmega 328 but on steroids. It's got lots more I/O, lots more memory, and JTAG support and all of that good stuff. It's got an RTC, so we've got a crystal here for a real-time clock. It's got that little clock crystal, the 32,768 kilohertz crystal. No, 32,768 hertz, not kilohertz. 32.768 kilohertz. There's an ATmega 32U4 as the USB to serial converter, and all of the I/O for that is broken out. So this is an extra thing that we did. One on the 16U2 that is typically used on, say, the Arduino Uno, it is only being a USB to serial converter, but it has all of its own I/O. I mean, it's basically the same processor as on a Leonardo. So with this board, all of that extra I/O was also broken out. So it was really two computers on one board. You could use the 32U2 just as a basic USB to serial converter, or you could have it running its own thing with all of, and you can see down here the 32U2 breakouts. So all of the I/O for the 32U2 is also exposed. And then header breakouts with extra headers, the normal shield headers. It's got the two ICSP things. It was like an everything board. It did everything. And there was a follow-up version to this that Philip did that even had a high precision DAC on it, so that you could do audio. You could generate audio signals, high fidelity audio signals, out of the Arduino. And so it got even more complicated. But this is the version as it was when we did the Possible crowdfunding campaign. Oh, you can see the little watch crystal down here for the RTC. And that is that board. But it was, my opinion was that it was too complicated. Now let's have a look at the bottom layer and we'll see all these cut track jumpers. Let's go single layer, flip it, and so we're looking at the bottom of the PCB here, bottom layer, and you can see all of these cut track jumpers. So there are the headers, which are the normal Arduino headers, and then there are solder jumpers, or solder pads on the inside of every header, and a cut track jumper for every I/O signal, so that you can isolate any of them by using a scalpel and cutting those little tracks. So the bottom of the PCB is covered in these little cut track jumpers, and you can see them down here as well. And over here is all of the I/O. So this is the I/O broken out for the ATmega 32U2. Anyway, a very capable board, but also fairly niche. And the result was that we did the production run for the crowdfunding campaign, and then I didn't produce any more. They were a pain to manufacture, they were a pain to test, and you'd needed to install a custom board profile if you wanted to be able to use these in the Arduino IDE. Alright, so the last 10 minutes of me showing you the Goldilocks was all lead up to showing you this, which is the baby bear. Now, the thing that I loved coming out of this project was the ATmega 1284p processor, because it really is just like a 328, which is on the Uno, but with bucket loads of RAM. It had more flash, it's got JTAG, it's got all sorts of cool things. And what I really wanted was a board that was much simpler than the Goldilocks, so I didn't have all of the complication I've just shown you. It was more like an Arduino Uno, but instead of the 328, it had a 1284p on it. And then all of a sudden you got that extra RAM and everything to play with, so you could have much more complicated programs running on it. Great for FreeRTOS and those sorts of things. So the result was, let me bring this other board up. I'll pull up the baby bear. Unfortunately, I'm going to have to pretty much end on this And we're not even going to get to look at the zero stick or any of the other cool things that I wanted to show you today. Oops. And I'll switch back to desktop. There we go. So this is the baby bear, and it's really a scaled down version of the Goldilocks. So if you consider that the Goldilocks is the ideal midpoint, the baby bear is like the simple lighter weight version, but it is an Uno with more RAM and flash, I suppose, is the simple way to think of it. Now this particular baby bear prototype that I have here was the first version that's got micro USB on it. I did then do an updated version with USB-C, and I don't even remember doing this. This must be not that long ago. 2018. Okay, so the original baby bear I did way back in 2013. I think this is a 2013 board. And then in 2018 I started updating it to switch it over to USB-C. And you can see that on the schematic, the USB-C connector is hanging off the side there. I haven't even integrated it all properly yet. This is a work in progress that you can see. And it's got the ATmega 1284p. But apart from that, this schematic looks very, very much like an 11. In fact, if I find the 11, let's do a quick comparison. So here I've got the 11, where's the schematic for that? Alright, so this is the schematic for the Freetronics 11, which is basically like an Arduino Uno compatible board. And if I switch between that, keep that one in your mind, and then you'll see that most of the stuff up around the top here stays the same. The ATmega 8U2 is the same, power supply is the same, the headers and everything. The difference is down here around the processor, and the USB is different. So if I now switch to the baby bear schematic, come on, you can do it, struggling on computer. You'll see that this part is the same. The difference here is that the USB connector is missing because I've got this big ugly USB thing down here, and the processor is different. So this board gives you something equivalent to an Uno, but with more RAM and flash. And for me personally, I thought that was a really nice balance. It avoids a lot of the problems in relation to things like lack of memory to load libraries like MQTT and Ethernet, and then have your own program running on it as well. There's no problems with that with this board because it's got that extra memory. So what I'd always had in mind, and the thing is that I did this, I prototyped it, and it works. Like, this board is fully functional, and it's a really nice board to work with. But I never put it into production. It's one of those projects that just I just couldn't do everything. So it ended up being put aside. My computer is doing a backup. Let's skip this backup. Why does it decide to do it now while I'm live streaming? So I never really followed through on it and put it into production. I just made some prototypes, tested them. They worked perfectly, and for some reason I just never followed through. But coming back to that thing earlier, so the thing about the Ether 10 not having enough memory, what had been in the back of my mind was to do the baby bear and then do an Ether bear. I wonder if I even got as far as that. I'm going to have a quick look back through my Ether 10. No, I don't think I did. What I was thinking of doing was taking the baby bear design and Ethernetizing it, adding a connector on there for the Ethernet, etc. So one possibility is to do a version of to do something that's like the Ether Uno, but with a 1284p on it. So it would have the same footprint as an Uno, it would work like an Uno, it would have the Ethernet, have USB-C, but have all the extra RAM and flash. Now, probably the reason, what's really held me back from going live with things like the baby bear is the need for a custom board profile. And back when I was doing this, so if you think back to 2013 when I designed this board, custom board profiles were really hard to install for most people. It was a barrier that just wasn't practical to get past. So it was long before the boards manager existed. It was before the library manager existed in the Arduino IDE. So in order to sell a board like this, I would have to have detailed instructions and explain to people how to download the custom board profile and where to put all of the files in their computer. And then you've got to explain that for Mac and Linux and Windows. And then you've got a tech support problem. It was all just too much. I couldn't face the idea of answering the same questions over and over again about people having broken board profiles and how to make it work. These days it's much easier. The boards manager makes it much simpler. If you've got a board that's available directly through it, then like I could publish a board profile on GitHub, get it referenced in the library manager, and then it's much simpler to install. So doing that sort of thing these days is much more practical than it was 7 years ago. Maybe I should get back to it. My objective though for the Ether Uno and the Ether 10 before it was to be 100% Arduino Uno compatible. So you should be able to compile a program and run it on an Arduino Uno with an Ethernet shield plugged in and take the exact same binary, like not even recompile it, just take the same binary, put it onto an Ether 10 and have it work 100%. That was my goal. And that's still the goal with the Ether Uno. So for the Ether Uno, I am not going to switch the processor. That's just like that's the way it is. I couldn't call it an Ether Uno and not have a 328p on there. It has to be that processor. But that doesn't rule out something like an Ether Bear in the future. So I could do a board based on the Baby Bear with a 1284p on it, and it would look otherwise just like an Ether Uno, but with a different processor. So if people care enough about that, this partly comes down to what people want. If there are people that care about wanting something like an Uno size board with Ethernet with the 1284p on it, then I can do that. Essentially what I'd be doing is swapping out this part of the PCB. This one here, this chip, is the WizNet chip, so that's the 6100. That wouldn't need to change. This chip here is the 328p. So what I would do basically is just drop a 1284p in place of the 328p. Obviously there'd be some routing changes and other stuff around this part of the board, but it's not a really radical change to the design, particularly if you don't really care about taking advantage of all of the extra pins and things on the 1284p. Now, one of the other nice things about the 1284p, and this is something that I personally found really useful, it's got more hardware UARTs. So on the 328, it only has a single UART, which means you can do hardware serial on pins D0 and D1 if you're looking at the pin numbering from the Arduino point of view. But if you wanted to do serial on anything else, you have to use software serial, which means you've got timing issues and you've got overhead in the code. It's using interrupts to get the timing right, all of those complications. The 1284p has, I think it has 4 hardware UARTs in it. So the result is that on the Baby Bear, is it marked on here? I can't remember. It doesn't look like it. But yeah, you can. That's really useful if you're doing something like talking serial to a host computer by USB, but also talking serial to, say, a GPS module or serial to an RFID reader, or like a combination of different things. So you can use serial 1.begin, serial 2.begin, and you just start those extra hardware serial ports on the appropriate pins. That doesn't really matter so much on a network connected device, but it's one of the nice things about the 1284p. basically the 1284p is a 328 with more. It's just stuff bolted onto it. It's cool. It's a nice processor. I like it. It is now well after 12, and I've been thinking that I really need to show you some stuff that I've been working on with Chris recently. But I'm kind of out of time, so that sort of stuff might have to wait. I'll just wave it in front of the screen briefly because it is cool and I want to show you where we're up to with it. Now, a quick check on comments. So, oh yeah, so getting back to the 3D mouse comment, there was some, there was, I think, a mention from Cable Tie about using a Logitech MX Ergo. It's great. It still requires modifier keys to get full orbit, but it's very comfortable. That's cool. Yeah, now I have a trackpad on my left as well, so you can't really see my setup here, which is unfortunate. Camera's in the wrong place. But in terms of control devices, I've got the keyboard in the middle, obviously. Then I've got an Apple trackpad on my left. I've got the Logitech trackball on my right, and I've got the 3D Connections wireless mouse in the middle. And I've also got a custom keypad which sends macros to Eagle. So just with a single key press, it selects different tools and does things like rip up and, you know, that sort of thing. Now, I've lost comments again. Too many windows open. Oh wow, there are a bunch of donations. I hadn't seen these. This is really cool. Thank you. So, yeah. So, Andy donated, said porridge for the baby bear. James did, Ether Bear porridge. Another donation from Peter Lawler, thanks. And Sion, some electrodes for streams that we can control via chat. Cool, that's very generous. Thank you to everyone that has donated. So, oh, and just because I just had to move this to get to this, you might have noticed that the robot over my shoulder has changed color. Which way do I go? There was the yellow one there previously. This one is running off the same controller, but it's different mechanicals. There's a new prototype being built at the moment, which will be there probably sometime this week. So, that's right, what I was going to show you was this little prototype. These PCBs just arrived on Thursday, and this really deserves like a proper demo. So I'm not going to go into it in too much detail right now because I should do it justice later. This is the Zero Stick, which is a zero deflection joystick. You can see it's got two load cells on there, mounted end on end. They've been machined so that they interlock and then they're cross-bolted. And it's into a little machined mounting bracket, which is with an 8mm rod, so that fits into the standard mounting base in a wheelchair for mounting wheelchair accessories. And it's got a TPU knob on the end, so this is sort of rubber. It's 3D printed, but it's soft. Mounted on the side here is a little PCB, which I designed. It's got two HX711 amplifiers on it. They're high, I think they're 24-bit ADCs, and they are reading the H bridges that are part of these load cells. So the strain gauges form an H bridge, so it can detect force. That is meant to have an AT-Tiny 84 on it, but I don't have any AT-Tiny 84s right now. I've ordered some, but they haven't arrived yet. On their way to me. So the idea is that the AT-Tiny 84 will be reading from those two strain gauge amplifiers and it'll be acting as an I2C device. So the whole joystick will be an I2C device that you can get data from. At the moment, I've got a Arduino Xiao connected to it, which is a SAMD21, so it's a Cortex M0 with USB-C, and it is doing USB emulation. And what happens at the moment, I was going to say the idea is, but it actually already does it. It's fully functional. Oh, and I've got some buttons in here as well for left and right mouse click, etc. With the firmware that's currently loaded on this, when you plug this into a computer, it comes up as a mouse, and then you can move the mouse cursor by moving or by applying pressure to the joystick, and then left and right mouse buttons, and one of them is a tear button which resets the 0 position of the joystick. Now, the reason this is called a 0 stick is that it's a 0 deflection joystick. It doesn't move. So what happens is, I'm going to mute that. So what happens is, for people who have very limited mobility as a result of something like Duchenne muscular dystrophy, many people with things like muscular dystrophy have very limited strength and very limited range of motion. So not only is it hard to push a normal joystick because of the lack of strength, but the actual range of motion has to be very small as well. So even a joystick that can be moved with very little force still can't be pushed far enough to deflect it. So the idea is that this will mount in the wheelchair frame, and if I get the position right, so imagine that's attached to the wheelchair frame, and then the operator's arm is sitting in an armrest, so there is a support under the wrist and under the arm. So the arm hangs in a position that naturally puts the fingers just over the top of the joystick, and then the load cells detect force on it. So what the person can do is then push the joystick, left, right, backwards and forwards with tiny amounts of force, and it's detected and then converted into mouse events, and then basically you can drive a mouse around just by applying force on this. And the amount that it takes is tiny. It's just little touches is enough to move the mouse. And because the joystick itself never moves, it doesn't matter if the person has limited mobility, because their fingers don't need to move. They stay totally stationary. They're in a fixed position on the joystick, and then they're just pushing it in different directions. And that's what's detected. It's really smooth. I'm actually quite chuffed with how well this is turning out. As I've been working on this, just within the last week, it's got to the point where this is smooth enough now, and this week I just added the left and right mouse buttons, that I can use this as an input device to a computer and drive the cursor around and select things and use it for menus, and it's very smooth and controllable. It's pretty cool. So Dodgy just asked how much force to read. It's hard to quantify, because at the moment we're taking raw values out of the strain gauges. These are 300 gram full-scale strain gauges, but we can easily, and I'm going to use bad terminology here. This is the whole thing about is it a measure of force or is it a measure of mass? So I'm going to use mass units to describe force. So 300 grams is full scale, but we can easily detect down in the sub 0.1 gram region. And so at the moment, the way the scaling is done in the software for this, and of course it's all tunable to suit the individual, full scale, like to be 100% effort, is probably around 4 or 5 grams of force being applied to it. So it's very small. And the reason for that is that this is to be used in a situation where the person has extremely limited strength. So the issue that Chris faces now is that his muscles have deteriorated to the point where he doesn't have the strength to activate, a normal joystick or whatever. So we're having to detect very small amounts of force. But the thing is that you could make a joystick like this, a zero deflection joystick. So the comparison, all right, this thing is, I think it's IP67 rated or whatever. Like you could chuck this in a bucket of water and it would be okay. And this is designed to be in the cab of a truck being operated by someone who may be actually driving the truck at the same time, maybe has gloves on and they're wet and muddy and they want to grab the joystick and like just slam it around. So that is a very different use case, but we could make a joystick using this principle just by using different load cells. So instead of 300 gram full-scale load cells, we could use like 10 kilo load cells, and you could build a system that someone, and make a larger grip for it, and you could make a joystick that someone could grab and apply force, and it's going to be fine. It won't be damaged. So the nice thing about this approach is that it can really be tuned to suit the individual. Now, I want to go into this in more detail and show schematics and board layouts and all of that sort of thing, but I'm going to do that another time because I think it deserves a little bit more time, and I'd have to be wrapping it up very quickly now. So, given that it is now 12:22 here in Melbourne at least, thank you very much to everyone for coming along today. I hope this has been interesting. And also, thank you very much for the people that have contributed some porridge for the baby bear and the ether bear. Now that I'm back revising the Ether 10 design to make the Ether Uno, I'm going to try to keep that momentum going. So after the Ether Uno, I'm going to complete the renovations on the Ether Mega to do the USB version of that, and I might switch that to the CP2102N as well. And while I'm in that headspace, that's really the ideal time to do things like revisit the baby bear and make an Ethernet version of it. So yeah, I think an Ether bear could be a very useful board. It's the sort of thing that you could drop in place of an Ether 10 and get some real benefits from it. Okay, so I'm going to wish you all farewell. I hope you have had a fantastic weekend so far, and you continue to do so. Please jump onto the Discord if you want to chat. I haven't been there very much this week, but I'm going to be catching up on messages, and I will see you all. Oh, James just said, just cut the back off the Ether Mega once it's done. Yeah. And everyone, go and make something awesome. I've got to remember how to end a live stream. What do? In OBS, I've got to go to end and click end. So thanks everyone. Bye.